Whew, okay. Oh, trials and tribulations of math teacher. You have no idea what I'm talking about. Don't worry about it. All right, so let's do exponential growth and decay. Take three. Okay, so the formulas are pretty simple. We're going to walk through them. We're going to do a couple practice problems. Hopefully they'll work this time, and then we will just go ahead and do it. Hopefully it'll be an outtake video soon, so don't worry about it. All right, exponential growth. The formula is y equals a times the quantity 1 plus r to the t power. Okay, so exponential decay is completely identical except for one little small thing. Instead of a plus, there's a minus. I know this is kind of a nasty thing in here. So take a look at the first formula. The only difference is it's a minus instead of a plus inside the parentheses. So what does this all mean? So A stands for the initial term. What did we start with? How much was there originally? What did we buy it for originally? Stuff like that. You'll be able to pick out what it is. The 1 plus always happens. And R stands for the rate. So it's a rate in a percentage form. But if I gave you a percentage form of like 8%, you're not putting 8 in for R. You're putting that percentage in as a decimal. So 0.08. Okay, so you're just going to move the imaginary decimal place over twice to the left. T represents time. And whether that's time in years or time in days, hours, minutes, seconds, whatever, it's whatever the problem is going to be giving you. Okay, so let's do a few practice problems. These are almost all going to be word problems, but these word problems are not like that, oh God, word problem thing. You know, it's going to be way easier to pick out the information. In fact, you're going to want them represented as word problems, trust me. So let's do this first one up here, and this is number 5, but it's not, it's number 1, okay? The number of bacteria present in a colony is 180 at 12 noon, and the bacteria grows at a rate of 22% per hour. How many will be present at 8 p.m.? So we have to understand which formula we're going to use first. This one is going to be a growth formula. And the reason is because it says the bacteria grows at a rate. Okay, so that is an indicator that I'm using the growth formula. So let's plug in things that we know. Y equals, we want to know the total, so we have to represent that way. A stands for the initial term. So the initial term is how many bacteria did we start with? Well, the bacteria present in a colony is 180. So 180 is what I'm going to put in for the initial term, or the initial amount. 1 plus always happens. Now the rate is whatever the percentage is that's given to you in the form. 22% is the rate here. But again, I can't put 22 in here because that's totally not correct. I am putting it as a decimal. So it's going to be 0.22 because I'm moving the decimal over twice to the left. So 1, 2. Okay. Now time is an exponent. And what is the time? How much time went from part A or part B to one or the other? Okay. So we started at noon and we're going to 8 p.m. So that's 8 hours. So 8 is going to be represented here as my exponent. If I plug this in the calculator, I can put in the calculator exactly how it tells me to. So there will be no surprises there. And I'm going to just write this out for you so you can see it. All I did there was I put that in the calculator as it said it. Okay, now I'm going to hit enter. And I get a value. That value is my answer. So the value is, it's about 883.39. Leave it rounded to the 10th place for now, just so we can get an idea of where we're going. So this makes sense. We start at 180 bacteria at noon, and it's growing at 22% per hour, which is a lot. Okay, my answer is going to be 883 bacteria at 8 p.m. All right, very good. Let's go on to number 2, which says number 6, but it's not. A house purchased for $226,000 has lost 4% of its value each year for the past 5 years. What is it worth now? Again, first step is we need to choose which formula we need. This one says that it is losing value, 4% of its value. So that means I have to use the decay formula. So again, the decay formula is identical except for a minus sign rather than a plus sign. So let's start our formula out. Y equals, how much was the house originally bought for, or how much was it originally worth? $226,000 is my answer. So I have to put $226,000 here. 1 minus always goes here. The rate is 4%. It's the only percentage that's going to be on the table here. So 4% is not 4, it's 0.04. Okay, remember, move that decimal over twice to the left. And the exponent represents the years. So it's 5 years because it says here 5 years. So it wants to know how much the house is worth now. You'll know right away if you're doing this formula correctly or not. You should get a value that's less than $226,000 because a house doesn't lose value and it's worth more in 5 years. It means it's going to be worth less, right? It's going to be less money. Okay. So when I put this in the formula, put it in the calculator, I get a value, $184,274.23. That's how much the house is worth right now. Okay, so you can't see the rest of that? There you go. Okay. That's my answer. Done. Okay, let's go to the last one. 1970 comic book has appreciated 10% per year and originally sold for 35 cents. What will it be worth in 2010? I don't know if you can see the rest of that. There you go. This is really close. Sorry. I wanted to make sure we got it. All right, so appreciated. Appreciate means it's going to increase in value or it's going to grow in value, which means I need exponential growth formula. Okay? Really quick, if this said depreciate, depreciate means it's going downhill. It means it's not going to be worth a lot. Decaying, okay, going downhill. So let's go ahead and put this in the formula. What was the comic book originally sold for in 1970? Long time ago. Not really. Okay, not really a long time. All right, so kind of, but not really. All right, so 35 cents is what it originally sold for. So 0.35 is what is my initial value. It's appreciating, so it's 1 plus a value. Okay, so exponential growth formula. The percentage is 10%, so it's 0.1. Okay, and how many years pass by? So it says from 1970, and it wants to know how much it's worth in 2010. That's 40 years. So 40 is the exponent. Okay, you're thinking it's going to be a huge number, but it isn't, right? So we bought the comic book for 35 cents originally 40 years ago, and it's going to increase or appreciate. It's going to get increased value 10% per year for that many years. So 10% for 40 years, it seems like a long time. It seems like a lot of money. So let's put it into the formula and see what the formula gives us. Okay. That comic book now, 40 years later, is worth $15.84. So you're thinking, wow, that's not that much. Well, it's just one comic book. What if you had 100 comic books? You know, it could be a lot more money. But that's how exponential growth and decay works. So exponential growth and decay are exponential functions. They start at some value that's low, and they really, really quickly shoot up to a good amount. Okay. In this case, though, 40 years is not really low, that shorter time period. So these are the three we're working on. I think there's some on your fever sheet. I don't have the answers, but we'll talk about them in class. Finally, video's done. Awesome. Goodbye.